Hello guys, and welcome back to another evening of algebra class. Tonight we're looking at lesson 2.5 where we're going to look at a bunch of different word problems. Before we get into these, I wanted to find some terms. I hope you're following along on pages 37 to 39 of your note-taking guide that was handed out in class. If you need to pause me to go get it, please do. Let's look at some of your vocabulary. Let's look at what an integer is. Hopefully you remember from chapter 1, that blue page that we did. What is an integer? Hopefully you said an integer is any whole number. It can be positive or negative, like -3, -260, or it can be positive, like 52 or 3001. All of these are integers. They're whole numbers. Integers are not fractions. I cannot have 1/4. I cannot have -1/4. Integers can't be decimals. I can't be 0.3. I can't be -0.06. Integers have to be any whole numbers, but they can be positive or negative. So what is consecutive integers? Well, so it has to be a whole number, but it has to be consecutive. So what does that mean? Well, consecutive things are things that happen back to back. So, for example, if I had 1, 2, and 3, these are consecutive. They go back to back. If I had -5, -4, and -3, these are consecutive. There's no skipping integers. The difference between any of them is 1. If I had -1, 0, and +1, these are consecutive. They come back to back on a number line. Think of consecutive integers. They have to be ones that are neighboring. So, -5, 4, and -3 are consecutive integers because they're all neighboring to each other. But if I had -5, 0, and 1, these are not consecutive because they are not neighboring. You have to skip numbers to get there. All right, so let's look at a word problem involving consecutive integers. If you're following along on your note-taking guide, this should be example 1 at the bottom or middle of page 37. So let's look at this problem. Here I have the sum. Oh, sum is important. Make sure you highlight or circle that. Now, the sum of 3 consecutive integers is 72. Always circle your numbers. All right, now with any word problem, the idea is I have to translate this to math. I'm going from English to math. So when I see sum, I know I'm doing addition. And I have 3 consecutive integers. And it is 72. So now I'm stuck trying to figure out how do I translate 3 consecutive integers into math speak. Well, let's use I, capital I, little I is something different in math. If I use capital I to represent integer number 1, and if I have consecutive integers, let's look at 3 that are consecutive. If I come up here and look at 1, 2, and 3, how could I represent that using a variable? If I use I for 1, then what does 2 equal? Well, 2 equals I plus 1, right? Because if I is 1, then 1 plus 1 equals 2. So if I equals 1 and 2 equals I plus 1, if I come up here, then I've also got 3. Well, 3 equals I plus 2. So if I have 3 consecutive integers, I can represent them using I plus 1, and I plus 2. Does that work for this? if negative 1 is I plus 1 is 0, because 1 plus negative 1 is 0. And if I add a 1 to that, it gives me 1. Or I plus 2. 2 plus negative 1 is a positive 1. So coming down here, the sum of 3 consecutive integers, I'm looking back at this again, meaning they happen one after the other, and the difference between them is 1. And I want to know what these equal. And I'm looking at the sum of 3 consecutive integers. So am I multiplying my 3 consecutive integers? These guys here. Am I multiplying, dividing, adding, or subtracting them? Well, go back to my language. The sum of. So I'm going to take the sum of 3 consecutive integers. I sum plus I plus 1 plus I plus 2. I have integer 1, integer 2, and integer 3 represented. So I've got this part, and I'm adding them together. I've got this part. Is in math is always your equal sign, and it equals 72. Cool, now I've got variables and I know how to solve for variables. So I'm going to rewrite this without my parentheses, and I get I plus 1 plus I plus 2 equals 72. By the way, your book is going to refer to this as n, and most books are. Anytime you have an integer, it just represents a number. So it's the same as a number, and a number plus 1, and a number plus 2. So 3 consecutive integers would be represented this way. So in your book, if you're following along with your note-taking guide, we have let either n plus 1 or I plus 1, or in their case x plus 1, equal my second integer. Which one of these variables represents my third integer? Hopefully you recognize I plus 2 is my third consecutive integer. All right, let's continue solving for I. All right, I have my equation here. And at this point, we're about midway down on page 37. So I need to combine my like terms. I have I plus I, always rewrite first, plus I, all right, plus 1 plus 2 equals 72. Now I can combine my like terms. I have how many i's here? 1, 2, 3. I plus I plus I is the same as 3 times I, plus, bring that down, 1 plus 2 is 3, equals 72. Well, remember, my goal ultimately is to get I by itself. So in order to get I by itself, I have got to deal with this 3 and this 3. Well, which one do I deal with first? Do I deal with the multiplication that's going on here, or the addition that's going on here? Hopefully you realize that according to what I learned last night, I have to deal with this part first. So 3i plus 3 minus 3, and what I do to one side, I've got to do to the other, equals 72 minus 3. So these cancel out, leaving me with just 3i equals 72 minus 3. If you simplify this further, 3i equals what? 69. All right, now I've got to look at what I'm doing over here. 3i, is this 3 times I, 3 divided by I, 3 minus I, or 3 plus I. Hopefully you recognize it's not either one of these, because they're back to back. And back to back also can't be division. If I have 3I written like this, it's multiplication. So how do I undo multiplication? I've got to divide. 3I divided by 3. And what I do to this side of my equation, I've got to do to this side. My 3's end up canceling, and I'm left with 1I, or just I, equals 23. Alright, so if I equals 23, I've got to go back up to this problem here. My first integer, remember I is the equivalent of my first integer. So if I equals 23, my second integer has to be back to it. So 23 plus what? This should be 23 plus 1. And my third integer should be 23 plus 2. So let's see if this holds. 23 plus 24 plus 25. Notice how these are back to back. 23, 24, 25. They're counting order. Equals 72. We're checking this, so I'm going to put a question mark here. 23 plus 24 equals 47. And 47 plus 25 does equal 72. So my first integer is 23, and because they're consecutive, I know that I2 equals 24, and I know that I3 is 25. Here is a similar problem that I would like you to solve on your own paper. It follows the exact same process as what we did up here. So if you need me to handhold you through it, let's check this out. But notice this problem. The sum of 3 consecutive integers is 147. I want you to find those integers. I'm doing the same thing. It's going to be my first integer plus my second integer plus my third integer, and they're all going to equal 147. Alright, see if you can solve this, and make sure to bring in your work tomorrow. Press pause, unpause me when you're done. Hopefully you got 48, 49, and 50. And if so, then you may proceed to the next video, and if not, then let's go over this. If I'm looking at this, I need to first put it into math speak. So sum of 3 consecutive integers is 147. Right, I've got sum of, and I've got is dealt with. 3 consecutive integers. How did I represent that? Well, up there I used I, and in your book it uses x. So let's look at x. Remember that if I'm talking about consecutive integers on a number line, they're the ones that are right beside each other. They don't jump around. They could be up here. It could be 100, 101, 102. They could be 99, 98, and 97. But the idea is that they are back to back and they don't skip spaces. So if that's the case, how do I find this? Well, let's say that my first, I have integer 1 and integer 2 and integer 3, and I know they come right after each other. So let's say this is x. What comes right after x? Well, it would be x plus 1. And what comes right after x plus 1? Well, x plus 2. If I look here on my number line, if I say x is 1, 1 plus 1 is 2, and 1 plus 2 is 3. So they come 1, and then x plus 2. And that's going to give me integers that are back to back. Now, am I multiplying? If I'm adding the sum of integer 1 then I'm adding integer 2, and I'm adding integer 3, and these have to equal 147. I just walked you through this. Sum, which gave me my addition, of 3 consecutive integers, which we determined was these right here, x, x plus 1, and x plus 2, and I'm adding all of these up, or integer 1, integer 2, and integer 3, and the total has to equal, right up here, 147. All right, let's look at plugging these variables in where they belong. So up here I said integer 1 equals x. So I'm going to come down here and I'm going to plug x in for integer 1. So x, what was integer 2? Well, it equaled x plus 1. So I'm going to plug that in for integer 2. And then what did integer 3 equal? Look up here. Integer 3 equals x plus 2. So I'm just going to plug that in. And this was all equal to 147. Cool. Now I know what I can do, because based off of last night's lesson, I know I can add like terms. I'm going to rewrite first. So I have x. I got that one. Plus x. I got that one. Plus x. Got this one. All right, I got all of my x's. Plus 1 plus 2. And all of that has to equal 147. Holy moly. Now I can move to combining like terms. X plus x plus x. How many x's do I have? It's the same as 3x. Good. Plus 1 plus 2 equals 147. Now 3x plus 1 plus 2 is plus 3 equals 147. Back to basic algebra. I've got multiplication going on here, and I've got addition going on here. Which one do I deal with first? Hopefully you said the addition. I can't divide both sides by 3 yet, so I've got to get rid of this 3. What I do to one side, I've got to do to both. Make sure to keep your equal sign in a line. 147 minus 3 is 144. Plus 3 minus 3 crosses out, so it's plus 0. And I'm just left bringing my 3x down. So 3x plus 0 equals 144. Now let's look at what I'm doing here. Hopefully you notice that 3x is the same as 3 times x. It's multiplication, so I've got to divide by 3. And what I do to one side, I've got to do to the other. So x equals... So x equals 46. Alright, so if x equals 46, I got to go back up and answer my question. My question was asking me to find the integers, plural. I had to deal with all of them. I wanted the 3 consecutive integers. So for me to find the 3 consecutive integers, I'm going to have to plug this back in. Okay. Let's look at this. I said x equals 46. Let's look back up here. Integer 1 equals x. So therefore, integer 1 equals 46. So integer 2 equals 46 plus 1, based on the fact that it was x plus 1. So 46 for x plus 1. So integer 2 is going to be 47. Integer 3, remember they're consecutive, so they go back to back. So integer 3 is x plus 2. Well, x is 46, and I add 2 to it, and I get 48. So my 3 integers are 46, 47, and 48. If I'm on a number line, double check. Do these come beside each other? Yes, they do. This could be a legitimate answer. Good job, guys.